Hi guys, welcome back to the channel. So, subject matter is this component tester. This is a Fnirsi LCR P1. It's actually a birthday present to myself, because the day after filming this is indeed my 43rd birthday, of all things. Ooh, lovely. Getting old. And you can use this thing to test capacitors, resistors, diodes, transistors, inductors. There's inner diodes as well, which you have to put on a separate function, and it can also do infrared remote control testing, but we don't really need the infrared remote control testing feature because we're not going to be using infrared remote controls, are we? So I'll put that capacitor there. I don't know why it's suddenly escaped. So I've got a nice selection of components here, and there's another resistor just off shot. I'll grab that. This came out of my 15K tub. But how do I know that that's 15K? I can't read those colour bands very well. You probably could there. So I'm going to just focus back down on the bench. We're going to have a go at testing something. So I'll just bring this off camera a minute, and I'm going to put this into the tester. So I'm just doing this behind the camera because it's actually a bit easier for me to do that. And then I'll bring it back in and show you how the component actually goes in. So there's a lever on that which you've got to lift up first. And that unlocks the socket. It's one of these sockets that I think you would put ICs in back in the bad old days. So let's lock that off. So I'll just show you how that's done. So I'll bring that in. So you'd lift that up, insert the component, then lock that back down. And we're now going to do a component test. So I'll zoom in there so we can see this. So we'll turn on the device. It'll come up with that, which is unknown, no component, or damaged. We haven't run the test yet. So if I've connected that right, that should show a 15K resistor. So it'll come up test in progress when you press the test button. That didn't take long to do. It's telling me it's a 15K resistor. I'm sure you can see that. I'll zoom in a little bit on the display. There we go. The display's covered in fingerprints, but it's a screen protector on there as well, which I'm going to leave on for the moment. So what we'll do is I'll turn it off. We'll lift that up like so. Just be very gentle, because that one should be gentle with. So that's a resistor tested. We're going to try this one next. I can't read colour bands on resistors very well because, as it turns out, I'm a tiny bit colourblind. And I discovered that during a job interview many moons ago. Yeah, a job interview for a place where I never want to go again. So that's now in. So we'll run a test on that one. That should be 100 ohms if I remember from checking it previously, because I actually have been playing with this behind the scenes. And so we'll run the test on that, and hopefully, no, that's actually registering that as a diode. Okay, that's not a diode. Just check the connection's done properly. Yeah, still showing that as a diode. I'll just double check the connections. Did this before with this resistor, I think, when I was messing around with it earlier, so I'm not sure why it thinks it's a diode, because it certainly isn't a diode. So I'll just do this behind the camera. There we go, it's come up with a resistance, and it's saying that one is 99.9. So I'll take that out, we don't need that now. I'll pop that over there. So, capacitors. Now we can read normal capacitors and electrolytics, so we'll start with a known good electrolytic. So I'll grab this one that's never been used before. It is rated, I'll show you this. It is 220 microfarad. I'll bring it up so you can actually see that. 16 volts. I have to lock the focus because the focus, no, I can't lock the focus right now, but that's fine. And let's go down there. So 220 microfarad, 16 volts. That's what we should get. So I'll put that in the tester behind the camera. So I'm sure you figured out now how everything connects to this. Let's check that's in properly. It appears to be in, so we'll run another test on it. I'll bring this up so you can see that. Just get focus on the screen and the device. And that's actually saying it's not connected. So I'll just double check my connections. We'll do that again. Always double check your connections. Okay, that's taking a bit longer now, so I think it's connected this time. Yeah, it says it's 238 microfarad, not 220. So it's a little higher than one would expect. But that's a brand new capacitor, so I'm not sure what. So this might not be that accurate anyway. It might not be as accurate as a Peak Atlas, which I can't obviously afford because they are quite expensive. Which is why I got this, which is actually, if I've not mentioned it already, is a birthday present to myself, because it's my birthday the day after filming this. I'm not sure if I've mentioned that, but if I haven't, I have now. So we can do a normal capacitor. This is a normal capacitor. No markings on this one, and it's pretty ancient, and it was removed from the Uniden Uniace 100. It was part of the 10 meter conversion. So I'm going to put that across. I think I'll put it across the far terminals because it looks like it would fit better if I do that. So that's now in. So if we zoom in there, we'll turn the device back on. It powers itself off after a little while. So that's now on and running the test. That is connected, there we go. And it tells me that's a 43 picofarad capacitor. That might be of some use to me. Yeah, because that was in the back of the Uniace 100. So now we go on to the capacitors I removed from the Uniden Uniace 100. And it's pretty much the same with all of these Unidens. And the audio lines and the realistics, all based on the same chassis as this. So this is my Project Uniace 100. I'll show you the capacitors in question that had come out and been changed. So this one here, next to this choke, this one here, and one down here, not too far away from the synthesizer. I changed one not too far away from that as well because it was a bit suspect. But the main four are, in case you haven't seen this or even seen it on any of Richard's videos, two up here, that one there, that one there. So those two are 470 microfarad, those two are 220 microfarad. Those ones I've put in, I think, are actually higher voltage rating. But I'll put that down, because we're not here to talk about that. We're here to talk about the capacitors that came out and how they fare on the tester. Whether they're actually working or, as is the case may be, not working. So the next thing I need to do is obviously grab the tester again, which I've just put to one side while I was showing you that. So we're going to start with one of the 470s first, because like I said, two 470s and two 220s. So this one that came out is a 470 at 10 volts. I think I did uprate the voltage actually. So we'll put that in there, into the tester. We'll close it down. And then it doesn't matter with the polarity, and also you don't have to worry about discharging them apparently, according to the instruction books. I have actually read that behind the scenes. So what we're going to do is we're going to turn the device back on, come up with a version and everything, come up with that, press the button to test it. So this is 470 microfarad. This one's actually reading 133 microfarad, so that one's pretty much failed. So I was right to change it, so we'll put that there on the little green dot of the CB. I don't think you could actually see that, to be honest. So I'll take the next 470. This one's covered in horrible glue, which I have recently discovered is apparently goes hygroscopic. There we go. So that's now in. Let's run the test again on that capacitor. It's actually saying it's not connected. Let's check that again. And run the test again. Okay, it's not seeing that. I'll just check that. Okay, let's give that another go. Because it's got such short leads, it's quite difficult to get it seated, because obviously the leads were trimmed down when it was manufactured back in 1981. Yeah, there we go. 431 microfarad, low ESR. So that would still have probably ran for a bit longer, but it could have failed. It could have failed the next day. So we'll check one of the 220s next. So let's have a look. I'll just show you this so you know what I'm testing again. So that's 220 microfarad, 10 volts. I'm going to put that into the tester. I'll have to make sure the connections are being made properly, because obviously the leads are trimmed. So now we're testing. This one's taken a while. And it says it's 52 picofarad, so that has actually failed. So that's this one. Got it in my hand there. 220 microfarad, 10 volts. Tester says it's 52 picofarad. So that's definitely failed. So we've got another one. And that completes the set. And I'll show you that one. You may not see it. It's upside down, but that's fine. 220 microfarad, 10 volts. Goes in there. I'll lock that off. Right, so that's now in. I'll bring the tester back in. So let's run the test. If you can't hear it, it does click when I run the tests, as well as the beep. I'm not sure if you can turn the beep off. So it says that one's 232 microfarad. So it's a little high, with a 0.34 ESR. So it's probably on its way out. There we go. So we've done capacitors. The next thing I'm going to do is I'm going to stick a diode in there. And this one is a diode. This is, if I look at my box, when I see the box, because I did have the box of diodes, it's a diode, but I'm just trying to remember what it was so I can actually tell you which diode it was. I think the 4148s actually, these ones, if I'm not too much mistaken. If I can't remember what they are, and then I find out what they are afterwards, I'll make a note in the description below, but I believe these are actually 1N4148s. It's a little dinky little diode there. So I bought a whole bandolier of these to make a programming interface for the Motorola GM350. Only really needed one, but it was more cost effective to buy a whole bandolier, which is why I've got quite a few of them. I'm going to put them into the far terminals rather than the nearest terminals. Doesn't matter which way around you put that in, because it will still detect it as a diode. So that's in. So that's now in. So we'll turn that on and we'll test. So I'll bring that into focus so you can see what's going on here. Yeah, it detects it as a diode. It detects that the cathode is on pin 2, which is correct by the looks of it. You can see the little black stripe. not sure. I'll zoom in a bit so you can actually see that. So it says the cathode is on pin 2, which is the black stripe there, and the anode is on pin 1. So I'll zoom back out, steady away, bring that down, and then you can see 1, 2, and the display tallies up with that. So that's definitely a diode. Come up with some characteristics for it. That just actually popped out with a connection as well. Let's put that back in and run another test just to see if that had actually skewed the results at all. Yeah, quite similar. So I'm just going to put that diode down there. Inductor, well, I'm going to have to do this in a slightly different way to how I would normally do this, because I don't actually have any fixed inductors, I only have variable ones. So I've got this variable inductor that I removed from some radio related circuit, not a CB radio. That did not come out of a CB radio, I think it came off a conversion board. So what I'm going to do is, the 3 pins at the back I've discovered I think are either an inductor or a transformer. This will read the inductance of that. So if I connect these one of these 3 supplied leads to that, the other to that. So I'm just going to make sure these aren't going to short against anything. So it comes with these 3 little clip-on type leads. They're good for transistors that are still in the situ and such like. So I'm going to plug 2 of those into the tester. It doesn't matter where I plug them in, as long as I plug them in. This should read this as an inductor. If I can get this in. Try again. And we'll bring it up. So it's a variable inductor. I'll turn that on. We'll run the test. It'll tell me how many henries is in that inductor. It says 499.1 microhenries as it's set. So what would happen if I connected it to the middle pin? Does that even do anything? Let's try not to do anything silly there. Let's see what happens if I connect it to the middle pin of the three on there, because on the other side it seems to read capacitance for some reason. Not sure if there's a capacitor in there. Yeah, it's reading an inductor again at 360.4 microhenries. So I'm wondering if that's just if that thing's a variable transformer or something. I don't know, because I got it off something, but the board wasn't marked. So kind of an idea of what that is. So it will measure inductance. That was the only thing close to an inductor I could find. Transistor. Now the only thing close to a transistor I could find was that. I'm just going to do that. And I'm going to put this one into the machine next. I'll put it in the bottom row. So it looks like I can do that. Just to be different. Let's make sure these leads are going to splay out and go in there. Okay, so it's in. I'll put it in the bottom row just to be different. Not sure if it'll read it down there. No, it says it's a capacitor. If I put it in there. So that's definitely not a capacitor. Let's try putting it in the other row. Try that. Yeah, if it's not connected properly, it'll give some weird results. Now it says it's a diode. So it's like it's ignoring. Okay, let's try moving that across one. So I think that's just reading the internal diode in there. Yeah, so if you connect it in the wrong manner, it'll give you some weird readings. There we go. Now it suggests it's an NPN transistor with the collector on pin 1, the base on pin 3, and the emitter on pin 2, which doesn't sound right to me for a transistor, because I would normally expect, if I bring this device up so you can see it, collector base emitter, that kind of thing. And that would be 1, 2, 3. But it's reading it slightly different there, which is interesting. So I don't know why it's doing that. So I'll see if I can grab something where I can probably... Well, not that, because that's a project I'm working on actually fixing up. I know what might be a good one. If I can gain access to it. No, there's no good. No, I can't gain access to that. I was going to try on a output transistor on a CB radio, but I couldn't get to the output transistor on that one. So let's not do that. Don't have any other transistor type components lying around, but it does measure transistors, so we should be okay. Actually, I will probably have to use this. This is if I can find a transistor I can gain access to. And can't see any transistors on that either, which is not ideal. Do I have any more transistors lying around, or was that the only other one I had? That's the only one I had actually. Or transistor type component. Let's have a look. Yes, I'm trying to find a transistor that would probably work, but that would probably give you an idea there of transistors. So I won't go too much more into that, because although I don't think that is a transistor, I'll have to have a look at the part number on that. But you can use this by hooking these leads over components. I actually could demonstrate that with components in situ. I don't have anything that I can easily gain access to, so I won't be doing that right now. So let's look at this tester. It's USB-C chargeable. So it comes with a cable to do that. It'll test Zener diodes as well, but I don't have any of those. To do that, you would put your Zener diode in here, where there's an A, 2 A's and a K, and it would probably have to go around that way. Not necessarily though. Turn the power on, and you would press this button down here. That would light up red, unless you test Zener diodes, which you will find those in CB radios. But you'll also find normal diodes in there as well, and they're also worth checking, especially the protection diode, to make sure it's acting as a diode and not a dead short circuit, but you can probably check that with a multimeter anyway. This also tests remote controls, but we don't need that. So, I hope you found this video of some use. Again, you don't have to have expensive equipment to repair and CB radios and check components and such like. I know the PCAP stuff is quite expensive. My budget definitely does not stretch to that right now. I was umming and ahhing about that at one point, but no, my budget doesn't stretch to it. This was a birthday present to myself, but it will be getting quite a lot of use here in here when I'm checking components in different radios, if I end up with more radios. So there you go. Because let's face it, you've got to check the components, haven't you? And it's from Amazon, this one. It's a little bit more expensive than the slightly cheaper ones, but it functions pretty much in exactly the same way. Fnirsi say you can upgrade the firmware on this according to the blurb on their website. I think you can probably get the firmware from there. There is a firmware upgrade mode. I'm not going to demonstrate that because I have no reason to upgrade the firmware because it's working how I want it. It does come with an instruction manual as well in English and Chinese, and as typical, Chinese is at the front. That's okay. It's just a case of put your component in, make sure it's in properly, put that down, press the test button, and it should test for you. But you have to switch it on anyway. So you lift the lever up, put the component in, press that down, press the button, and it will test the component. If you want to switch it off before the automatic power off, press the whole test button, it'll turn it off. If you want to test Zener diodes, you would press this one before you press the test button. So there you go. So, hope it was interesting, and If you like it, give it a thumbs up. But if you didn't, there's always another button for that. There'll be a video pop up on the screen that the algorithm thinks you might like or might not like. Well, it thinks you like it. You can subscribe to the channel and ring the bell for notifications when I upload new videos or go live, which the latter is very rare at the moment. And also, if you want, you can become a channel member for some early access videos. This one isn't early access because this one's part of the Useful CB Repair Aids playlist, so it'll be going pretty much straight out on the 7th of April, which is indeed my birthday. Fun. Anyway, so thanks for watching this one, and I will be back with another one very soon, and hopefully we'll be getting some on the air stuff soon, because like I may have said in a previous video, I serviced my President Grant too. So catch you in the next one. 7-3 for now. Okay, small bit of bonus extra footage, because I like a bit of bonus extra footage. So this is a BC547 transistor, standard NPN transistor, which I happen to know should read correctly on the tester. Now, I tried another transistor device, as you know, and it read rather obscurely. This one should theoretically read in a way that I would expect a transistor to read. He says, not sure. I've just desoldered this from a project that isn't probably going to see the light of day. There we go. So it is reading as I would expect it to read. The base is on pin 2, which is the middle pin. So the collector is on pin 1, the base is on pin 2, and the emitter is on pin 3. And that's exactly the pin out of that type of transistor. I know because I've actually looked at the data sheet before installing it in what I installed it in. So as you can see, that transistor read as you would expect. Collector, base, emitter, 1, 2, 3. This is rather odd because when you test it, it reads as an NPN transistor with collector, base, emitter 1, 3, 2, which I find a bit odd. So perhaps this isn't a transistor as such. I don't know what it is, but it is reading as an NPN transistor. I'm going to bring this in so you can actually see the markings on it. See if we can zoom in on that and focus on that. Not sure if we can. Where is it? It's somewhere down there. So it does have markings on it, but I'm not sure what it's supposed to be. But it is reading as an NPN transistor, which is rather unusual. So I'll zoom back out because I still can't see the markings on it. There we go, now we can. So yes, I don't think that. See if we can focus a bit more on that. There we go. Yes, I don't know what that is. But it was reading as an NPN transistor, so I'll zoom back out so you're not looking at a totally zoomed in bench. So yeah, tried a proper transistor in it because I finally found one and it read exactly how I expected it to. So this tester's fine. The other thing I may or not have mentioned is this little carrier board that fits across there for surface mount components. It doesn't actually say how that connects, whether you have to... here's how you do it. So what you would do is you would unplug the socket, as so, if you want to do this, and I only just discovered that, and then plug this in instead in its place. And it would go as shown below. So it didn't go over the things like I thought it did. It goes in like that. It's on sockets. So that will now test diodes, capacitors and resistors. Although I think that might be xenodiodes, but it's not marked as such. And transistors, all on there like that. Surface mount devices. I don't have any surface mount devices to test because I don't tend to work with them. But modern radios do have a lot of surface mount in them. So You have been warned. So I'll put that one back on, I'll lock that off. So that is the Fnirsi LCRP1. I got that from Amazon. Birthday present to myself. All explained in the video. And there'll be a link to the product listing on Amazon. I'm not an affiliate, so I won't get anything for it. It's just a link down there so you can go and buy it. So I'll catch you in the next one. 7-3 for now.